When you see a massive steel building going up, you notice the huge cranes and the giant beams. It's all about the scale, right? But what if I told you the real strength, the secret sauce, is in something you can barely see? It's in the thousands of tiny bolts holding it all together, and the insane level of precision that goes into every single one. So how in the world do you make sure that every single connection in a building this big is absolutely perfect? I mean, we're talking about thousands of critical points, and each one has to be flawless for the whole thing to be safe. Well, let's dive in. We're going to take a look at the official playbook that turns a giant pile of steel into a rock-solid skyscraper. The first step happens way before anyone even picks up a tool. It's all about creating the perfect plan. Building something this strong isn't about guesswork or just doing it right. It's about having a meticulous, pre-approved rulebook for every single action. And this right here is what that rulebook looks like. It's called a method statement, and it's basically the master instruction manual for the most critical jobs. In this case, it's all about how to tighten the structural bolts. This document has to be written, reviewed, and then signed off on by literally everyone: the builders, the engineers, the client, the whole team. And this isn't just some piece of paper they file away. No way. This plan gets passed around, marked up, and refined. Experts from all the different teams pour over it, asking questions, flagging potential problems, and suggesting improvements. The goal is to make it perfect before any real work even starts. And here, you can actually see that process in action. It's pretty cool. A reviewer makes a comment, a really simple but important one. Hey, you need to clearly show the correct way to install the nuts and washers. And the team's response is simple. Noted. They go back, add detailed diagrams to the plan, and make sure there's absolutely no room for error. It's this constant back and forth that makes the plan so robust. All right, so with that bulletproof plan approved, the actual work can begin. And first step is the most common job: connecting those massive steel beams to other steel beams. Now, you might think it's a bolt. How complicated can it be? But in this world, every single little piece has a right way and a very, very wrong way to be installed. The direction of the washers, the direction of the nut. It's all absolutely critical to get the strength they've calculated. So check this out. A washer isn't just a flat disc. One side is perfectly flat and the other is a little bit sloped or slotted. And the rule is simple. The totally flat side always goes against the steel structure. This gives you a perfect even surface for pressure. The other side, the slotted one, goes against the parts that turn, the head of the bolt and the nut. And this diagram just shows you the level of detail we're talking about. Even the nut has a right way up. The side with the manufacturer's little markings on it has to face out, away from the steel. And they don't leave it to chance. This picture is taken right from that plan we were talking about, making it crystal clear for the workers on site. O is right, X is wrong. No confusion possible. Okay, so let's walk through the whole process. First, they put the bolt through with the washers on each side, facing the right way, of course. Then they thread on the nut, again, making sure that marked side is facing out. But here's the really important part. They don't tighten it all the way. Not yet. They make all the bolts in that connection just snug. This pulls those huge steel plates into perfect alignment. And only then, once everything is sitting perfectly, do they do the final tightening. And that final tightening, it isn't just about making it really tight. It's a science. They use a special wrench that measures the rotational force called torque. And as you can see, the bigger the bolt, the crazier the force required. That big M30 bolt needs 1,200 Newton meters of torque. That is a massive amount of force, and it has to be exact. So that's how they connect steel to steel. But what about the most important connection of all? How do you attach that entire steel skeleton to the concrete foundation it sits on? Well, that's a different kind of bolt and a different procedure altogether. Here's the key difference. Those connection bolts we just talked about, the steel-on-steel ones, they need that super precise measured torque. But the anchor bolts, the ones holding the whole building down to the concrete, they have a different standard. They're just tightened until they are snug tight. So what on earth does snug tight actually mean? It sounds kind of vague, but it's a real engineering term. It basically means as tight as an experienced worker can get it with a normal wrench, using their full strength. The goal here isn't to hit a number. It's to make absolutely sure that the huge steel-based plates are pulled down into firm, solid, unshakable contact with the foundation. But hold on, the job isn't done just because the last bolt is tight. Not even close. Now comes the moment of truth, the verification. Every single one of these critical connections has to be inspected, checked, and signed off on. And this is where it all comes together. The inspection happens right there, on the steel beam, hundreds of feet in the air. You have an inspector literally watching over the worker's shoulder, confirming that the special calibrated wrench clicks at the exact torque value that the plan calls for. As soon as that torque is confirmed, the bolt gets marked. The inspector takes a paint marker and draws a simple line across the nut, the bolt, and onto the steel plate itself. That little line is basically a stamp of approval. It's a clear visual signal to anyone who sees it that says, this one's done, it's perfect, move on. And here's the mind-blowing part. They do this for every single bolt. Imagine a skyscraper with tens of thousands, maybe hundreds of thousands of these bolts. Each one gets tightened, checked by an inspector, and then marked by hand. The sheer amount of repetitive, painstaking work is just incredible. And the quality checks are so specific. Get this. Here's a direct quote from the quality standards. The bolts will be more than 3 threads appearing shall be accepted. That means, for a bolt to pass inspection, you have to be able to see more than 3 of its threads sticking out past the nut. It's another one of those tiny, measurable details that adds up to total safety. So really, that's the big takeaway here. The unbelievable strength of these huge buildings doesn't just come from having big steel beams. It comes from this almost microscopic focus on the tiny details. The direction of a washer, the exact force on a nut, a simple line from a paint pen, all repeated perfectly, thousands and thousands of times. It really makes you look at the world a little differently, doesn't it? I mean, when you think about all the complex things around us, from a bridge to a plane to the phone in your hand, what other invisible, meticulously planned, and perfectly executed procedures are working in the background, just holding our world together?